ELEC2 2019 question 2. Okay, so part A. The block diagram for a PIC microcontroller is shown below. Which block contains the whole program? So for part 1, which block contains the whole program? Okay, I've got a diagram similar to the one from the exam paper. And what we need to realize is that the only block that contains the whole program is the memory. And if you think in terms of when you boot up on a PC or a PIC, all of the program needs to be in memory in order for you to actually be able to run the program. Okay, A part 2. The block has which block has the task of synchronizing data transfer and manipulation? Well, synchronizing is the key word here, and the block that does the synchronizing is the clock. Okay, part B1. Okay, so for part B1, we've got this block of code. And so if we read through what's said, so for B, a student designs a direction indicator system for a bicycle. It has 4 LED lamps, 2 at the ends of the handlebars pointing to forwards and 2 either side of the rear wheel pointing backwards. 3 switches mounted at the centre of the handlebars, 1 to operate the front and rear left-hand LEDs to indicate a left turn, 1 to operate the front and rear right-hand lamps to indicate a right turn, 1 to turn on all LEDs as a hazard warning. When an LED lamp is switched on, it flashes at a frequency of 2 Hz. Pressing either turn switch makes the corresponding LED lamp flash 10 times and then stop. Pressing the hazard switch immediately flashes all 4 LED lamps. For part 1, the left turn switch is connected to bit 0 of input port A. When the switch is pressed, it outputs a logic 1 signal. The right turn switch is connected to bit 1 of port A. Again, when pressed, the switch outputs a logic 1 signal. The program checks whether the left turn or right turn switch has been pressed. The subroutine flash left causes the left-hand indicator to flash on and off 10 times. The subroutine flash right has the same effect on the right-hand indicators. Complete the code for that section. Okay, so here's our block of code. Now, what we need to ascertain as far as this is concerned is that this is a checking piece of code, or it polls, and it's going to look at port A0 and it's going to look at port A1. And so if we look at the code in the top 2 lines, we can see that the second line is going to call flash left. That means we're looking at A0. And so let's have a look at the very top line. Does that make sense? So BTFSC port A. And if that was a 0, if A goes high, would you go, if A0 goes high, would you call flash left? So would the code go to the second line? Well, the BTFSC is looking for a low to skip. So to go from, if there's a low, it skips from line 1 to line 3. If it's a high, it goes to line 2. So we can safely assume that that's a 0 for the top line. If we look at line 4, we've got call flash right. Well, that might suggest that line 3 is similar to line 1. And the only difference is that instead of port A, 0, what we're going to have is port A, 1, and it does exactly the same. And then at the bottom, we've got a go to, and because this is a checking piece of code, what we're looking for is it to loop, and it's going to loop back to the title of the top line, which is loop. Okay, so for part 2. The following code gives a subroutine which is called to operate the left-hand LED lamps. It uses a quarter-second delay subroutine called quart. And then we have 3 questions. Now, in order to really understand and get the most out of these questions, you've got to understand the code. And if we go through this line by line, hopefully this will give us enough information with the text that we've already had in order for us to be able to talk very, very clearly in terms of our answers. So flash left, MOVWF, W store. Now this is a classic piece of code where you're moving whatever is in the working register to a register called W store, and normally it's used to protect whatever is in the working register before this particular subroutine is called. Then we've got MOV-LW D10. Now MOV-LW is moved the literal, which is 10, into the working register. And then we've got a title repeat, MOVWF count. Now this is basically taking whatever is in the working register, which is the number 10, and putting in a register called count, which can then be used later. Okay, so the fourth line, MOVLW D5, that's similar to the second line, but this time we're moving the literal number 5 into the working register. And then the fifth line says MOVWF port B. So we're going to move that number 5 to the register, which is called port B, which is one of our outputs. Okay, so why move the number 5? Well, if you think in 4-bit binary, 5 is 0101. So you've got two highs. Could these two highs correspond to the two left-hand LEDs? We'll come back to that. Okay, so the sixth line, call quart, and then we've got CLRF port B, which is to clear the register port B to make them all the output 0. And then we've got call quart again. Okay, so the 6th, 7th, and 8th lines are probably to do with you're making the outputs go high for a quarter of a second, you're clearing them, you're making them go low for a quarter of a second. So you've got a ½ second routine there. Well, a ½ second in terms of a period is a frequency of 2 Hertz if it's a repeating piece of code. So that might correspond to the text that we've had earlier. And then the 9th line is DECFSZ count F. Now this is a decrementing piece of code, and it's looking for the 0 flag to be high, and if it's not high, it basically goes to the 10th line, which is go repeat, and that gives us our looping piece of code. But if the 0 flag goes high because the number in count, which has been decrementing from 10 to 9 to 8, etc., if that goes to 0, then the 0 flag goes high, and you get a skip. So it skips the line go to repeat and goes to MOVF W store, W. Right. So we know what the go to repeat is. It's the looping piece of code. MOVF W store, W is moving from the register W store. So we moved items in line 1 into a register called W store. This is actually moving it back from that register into the working register, and that's the W at the end. And then we've got return, which basically takes us back to the main program. Okay, so for part 1 of this question, identify which ports and which pins of that port are connected to the left-hand LED lamps. Explain how you arrive at your answer. So not only do we need to identify, what we also need to do is do a bit of explanation. Okay, so let's have a look as far as this is concerned. So if I just click on my diagram here. So the ports are B0 and B2. Now these were, if you think in terms of binary number 5, which was outputted to port B, then B0 is the least significant bit and B2 is the third least significant bit. These were the two that went high. And so for the explanation, the literal 5 is outputted to port B, and 5 is 0101, so therefore B2 and B0 go high. Okay, for part 2, why are the instructions MOVWF W store and MOVF W store, W needed? Well, as far as this one's concerned, MOVWF W store moves the data from the working register to the register W store, and this is all about protecting it for later. And MOV W store, W returns the data back from W store into the working register. Okay, part 3. What value is stored in the register count when the program completes the subroutine and returns to the main program? Now this is down to that line, which was DECFSZ count, F. Remember, that was looking for the 0 flag to go high, and in order for the 0 flag to go high, you need a 0 in the count register. So as count needs to progress to 0 in order for the 0 flag to go high and the last 2 lines of the subroutine to be accessed. So there's our explanation for the 0, not that they're actually asking for that. Right, so part C, part 1. The hazard switch is connected to cause an interrupt when pressed. Why is it important that it's connected in this way rather than it be polled during the main program? Okay, so for this particular part of the question, if I just delete that, so hazard switch enables a subroutine to be called immediately. And so this is a decision in your programming. Do you want it to be called immediately, or are you happy for a slight delay to occur? Because polling is where a line of code is regularly called within a subroutine. This could cause a delay in the hazard subroutine being called. So when you're polling, because you're looping, there could be delays in terms of a particular line of code being accessed if you've pressed the switch and there's a particular hazard that needs to be responded to. But if you've got a hazard switch which basically interrupts the code, then it's done immediately. And the last part of this, C2, is complete the circuit diagram to show how this hazard switch and any other components needed are connected to the microprocessor. The switch is a push to make type. Okay, so what I've done here is I've shown the datasheet picture for the PIC. And so just need to realize that is there for your use. And what we need to be looking at as far as this is concerned is which input on the PIC do we need to use. Now, hopefully, if you look down the left-hand side, what you'll see on the 6th pin down is RB0/INT. And the INT is the interrupt, and that's key as far as this is concerned, because what we're going to do is we're going to use that one as our input to the PIC. Now, all we now need to do is add the components, and the components as far as this is concerned are a switch and a resistor. In reality, it doesn't matter which way round the switch and the resistor go, and it's a push to make switch that we're going to need to use. But what you'll find is if you look at enough questions where this has come off in the past, then the switch is invariably at the bottom. So what I'm going to do is just put that switch at the bottom, and we're going to stick a resistor at the top. And that should suffice as far as this particular question is concerned. So that completes question 2.